Converting between radians and degrees. So there's different ways to measure angles, and those are called radians. That was one of the things that I was referring to on your calculator. If your calculator was in DEG for degrees or RAD for radians, that's what it was referring to, is the radians. So we're going to talk about radians. So first of all, we're talking about a circumference of a circle, because if you were to take an angle and go all the way around, it basically makes a circle. Well, the circumference of a circle, if you want to find it, is 2 pi r. Hopefully you remember that from way back. Now let's just say the radius is 1, because when we get into the unit circle, we always have a radius of 1. Well, if r was 1, then 2 times pi times 1 is just 2 pi. Now for all of these, we are going to be leaving the pi. We're not making an approximate decimal, so we're leaving the pi alone. So if I were to start at the very beginning, it is always right here. This is where we start. It's our initial point of our angle. If you went all the way around this circle and came all the way back, this has a length of 2 pi, because going all the way around the circle has a length of 2 pi. Well, we can find some other lengths then. So if all the way around is 2 pi, then halfway around is just pi. So halfway around gets you just over there. Well, if that's 1 pi, then halfway there would be right here. So this would be half of a pi, or pi over 2. We are going to be writing them as fractions. So if this is half a pi, a whole pi, so half of a pi, a whole pi, this must be 1.5 pi's, also known as 3 pi over 2, because 3 halves is 1.5. And then 4 pi over 2 makes it 2 pi, because 4 over 2 is just 2. Okay, well, what's in between? So from the beginning to here is half. What's half of a half? That's a fourth. So this is a pi over 4. So this is 1/4. So this is 1/4, 2/4. Then this one must be 3/4, so 3 pi over 4, 4/4, which is 1, 5/4, so 5 pi over 4, 6/4, which reduces to 3 halves, 7/4, so 7 pi over 4, and 8/4 reduces to 2. So these are some basic radians going around the circle. So we can do a couple things. For instance, if you went halfway around the circle, well, that is 180 degrees. 180 degrees is the same as pi radians. So this is actually the one that we're about to use, because we're going to convert between degrees and radians. And we are going to use the idea that 180 degrees and pi land you in the same exact spot. So here's how to convert between degrees and radians. If you are given degrees and you want to have, so this is the desired measurement, and you want to have radians, then you multiply by pi over 180. Now, if you're taking chemistry class, you will have done something very similar, because what happens is the degrees and these degrees cancel. So you're canceling off units, leaving you with just the pi for the radians. Now, if you are given radians, but the desired unit is degrees, what you're going to do is you're going to multiply by 180 over pi. So again, the radians is going to include a pi, so you're going to be able to reduce your 2 pi's. The radians and the pi cancel out, leaving you with just degrees. So you either multiply by pi over 180 or 180 over pi. So let's practice this. So make this little table. We're going to convert each of these. This is like a little table. So first you're going to take 30 degrees and we're going to change it into radians. So I'm going to multiply 30, or also known as 30 over 1. I'm going to multiply that by pi over 180 degrees. Now, one of the reasons, again, that I know I am multiplying it by the correct fraction is I can literally cross off the degrees in the numerator and denominator, leaving me with pi's. Now, the only other thing we need to do is reducing of some fractions. So think back to like 6th grade reducing of fractions. First of all, if I divided them both by 10, the zeros are gone, so I can just cross off those zeros. And then 3 and 80, what can I divide 3 and 80 by? I can divide them both by 3. So 3 divided by 3 is 18. And 18 divided by 3 is 6. So this becomes pi over 6, because I only had a 1 with my pi. Okay, so now we're going to start off with radians. We're going to have 5 pi over 2, and I want to change it into degrees. I'm going to multiply this by 180 over pi. And the reason I know I did it in the right direction is I can reduce the pi's, because I don't want it to be in radians anymore. I now want it to be in degrees. So I have a 180 times 5 on the top and a divided by 2 on the bottom. Well, before I multiply, I can cross reduce. I can divide the 180 and 2 by 2. 2 divided by 2 is 1. 180 divided by 2 is 90. And if I multiply what's left over, 90 and 5 are both on the top, and that is 450 degrees. So 5 pi over 2 is the same as 450 degrees. Okay, let's start off with negative 200 degrees. I'm going to multiply that by pi over 180. And I know that I wrote my fraction the correct direction because I can cross off the degrees, and the degrees are now gone. I do need to do some reducing of this fraction. So first of all, I'm just going to divide both of them by 10, essentially just crossing off the 0, making things a little easier for me. So now I have a 20 over 18. Well, I can divide both of those by 2. So 18 divided by 2 is 9. 20 divided by 2 is 10. And what I'm left with is a negative 10 and a pi on the top. So the negative, the 10, and the pi on the top. And on the bottom, I'm left with just the 9. So negative 10 pi over 9 radians. Okay, let's try one more. 35 pi over 12. So if I want to take that radians and make it degrees, I'm going to multiply by 180 over pi. And I know I wrote my fraction the correct direction because I can cancel my pi's. So 180 times 35 over 12. I definitely want to do some reducing before I do anything. Well, 180 actually can be divided by 12. So 12 divided by 12 is 1, and 180 divided by 12 is 15. So all I'm left with is a 15 times 35, which is 525 degrees. So that is how you're going to convert between degrees and radians.